What is up, 7th grade? This is lesson 61 and 62 because both concepts are pretty simple and I think you can learn both of them fairly quickly. So we're going to be talking about area of parallelograms as well as classifying triangles, both by sides and by angles. So the first thing we need to remember is the area of a rectangle. Remember, when we're talking about the area of a rectangle, we take the base length and we multiply it by the height to find out how many squares it would take to fill up that rectangle. So the area of a rectangle is just base times height, b times h. And we're talking about a parallelogram. Realize that if we were to cut this right here and to move this triangle right here, we would have the exact same shape as a rectangle, where from here to here would be the same thing as the original from here to here. And this height, so the base would be the same, so it'd be base times, and the height would be the height that's perpendicular between the two bases. So it has to be the perpendicular height. Something else that's cool about parallelograms is that opposite angles are the same or congruent. So this angle up here is the same as this one's the same as this one. And adjacent angles are supplementary. So any two angles, this one and this one, or this one and this one, this one and this one, or this one and this one, any two angles that are next to each other are supplementary, or they add up to 180 degrees. So just try one of these real quick. It says, first off, here's a parallelogram, and we know that this angle right here is 30 degrees. So then we need to find out what the measure of angle D is. Now we remember that all three angles in a triangle add up to 180. I know that this one right here is 90, so I'm going to subtract 90 from that and get 90. And then I'm going to subtract 30 from that. A 9 minus 3 is 6, so it's going to be 60. So the measure of angle D is 60 degrees. That we already knew how to do because we were just looking at this triangle right here. Now, if we look at the measure of angle DCA, well, they already told us that one's 30 degrees. And then, what's the measure of angle BAC? BAC, well, this little piece is going to be the same as this little piece because those two are both 90s. So BAC would also be 30 degrees. And now what's the measure of, so this is 30, DAB. DAB. So it's this whole angle here. We're looking at this angle. Well, I know this one's 90 because it's a right angle, and that one up there is 30. So I'd add those two together. 90 plus 30. 0, 9 plus 3 is 12, so it'd be 120 degrees. Now the area on this is going to be the base times the distance between these two. So we're not going to use the 7, we're going to use this height here. So it's going to be 14, the base, 14 inches, times the height, which is 6 inches. We do 14 times 6. 6 times 4 is 24. 6, 7, 8. So the area is going to be 84, and then inches times inches is inches squared. Something else we might be asked to do is to solve for x given a parallelogram like this one down here. So remember that opposite angles like this are congruent. So if I were to have one like this, I would say 3x plus 4, that's that one there on the left, it's going to equal to the one up here on the top right, 58. So I'd subtract 4. I end up with 3x is equal to 54. Divide by 3. X is equal to, let's see here, 54. Divided by 3 goes in that one time. So it goes into that 8 times. So x would equal to 18. Now just as a cautionary, if they had given us something down here in the bottom right corner, let's say if they had said that this was 62, I'm just making that up. Those two, this angle and this one, are supplementary. So if we had been given ones that were next to each other, I would have said 3x plus 4 plus the 62 is equal to 180, and would have solved it from there. I don't know what that would work out to, or if it even work out nicely. But if they were next to each other, then I would say they equal to 180 when I add them up. Alright, so now moving on to 62. As we remember about classifying triangles by their angles, we first need to remember the three different types of angles. So there's acute angles. Those are ones that are smaller than 90 but bigger than 0. There's right angles. I call those the girl angles because they're always right. Those have a measure of 90 degrees, and they're marked with a little square there in the corner. And then obtuse angles, which are bigger than 90 degrees but less than 180. There's also straight angles, but that doesn't really, we don't necessarily have to remember that for this lesson for today. So if we're classifying them by angles, if all three angles are acute, then we call that an acute triangle. If we have one right angle, we call it a right triangle. And if we have one obtuse angle, we call that an obtuse triangle. Notice we can't have more than one right angle, because if I drew two right angles and had three sides, it wouldn't even make a triangle, it would just make like a field goal kick or something. Same thing with obtuse angles. If I had two obtuse angles and three sides, I wouldn't be able to create a triangle with only three sides. So if I'm going to classify these here, notice for A, it has that one right triangle, or one right angle, so I'm going to call it a right triangle. For B, I'm noticing this one up here looks bigger than 90 degrees, so I'm going to say obtuse triangle. And then this one, that one looks acute, that one looks acute, and that one looks acute. So I'm going to say acute triangle. Now I will point out this angle in A are both acute. But because I have one right, I call it a right triangle. So in order to be acute, all three of them have to be acute. Same thing goes here for B. That one and that one are both acute. But because it has the one obtuse, we call it an obtuse triangle. Now we can also classify triangles by their side length. When we classify them by their side length, there's three different names. If all three sides are the same, we call them equilateral. We can tell that if all three sides are the same, or if all three angles are the same. So either way we can see if they are equilateral. If all three angles are the same, then I know all three sides will be the same. Now, if only two angles are the same, or only two sides are the same, we call that an isosceles triangle. And then if all three sides are different, or all three angles are different, then we call that a scaling triangle. So if we look at these right here, if we're just classifying by side length, as the side length of 3, of 4, and of 5, none of those are the same, so we would say scaling triangle. On this one, notice it's 4, 4, and 4. All three sides are the same, so that'd be equilateral. And then for F here, notice we have 5 and 5. Two of them are the same. The third one's different, so that means it's going to be isosceles triangle. Now, on your quizzes or on your tests, maybe even on your homework, they're going to ask you to classify them by both. Notice the and. It says by angle and by side. So for this one, notice if I'm classifying it by angle, this one's acute, but this one's a right angle. So I'm going to say this is a right. And then by side length, again, I'm going to look at these. Notice all three of these are different. If all three angles are different, that means we're going to call it a scaling. So I'm going to call this a right scaling triangle. So that would be my answer if I'm classifying it by both. I'd use the three options for angles and the three options for side length and classify it that way. Alright, so that's lesson 61 and 62. You now know how to find the area of parallelograms and how to classify triangles, both by side length and by angle measure. Make sure you get your worksheet. That's your homework for today. You guys are going to do awesome.